In this video, I'm going to show you how to develop the compound interest formula. Let's just go ahead and look at, in general, finding interest. If this is my original principal, and then you find the principal times rate here, what we would end up doing is we would end up adding together these values to get the total. Okay. Well, if you look at these two expressions, so you've got original plus the rate times principal is the interest. So this is principal plus interest. Let's look at this expression though. They both have a p involved, so you can do p times, and then you have 1 plus r. If you think about this, relate it to finding sales tax. The cost plus 1 plus or times 1 plus the rate. It's very similar to that. Well, then let's figure out what happens then when this is the second year around. Well, the second year, this is our original. Our original is now P 1 plus R. And we're going to add to that principal times the rate. So again, here's the principal, 1 plus R, times my rate. Now, what we're going to do is algebraically, we're going to distribute, combine all of my like terms, and let's just see what it is that we have. All right, when I distribute the P with the 1 plus R, we get P plus PR. Plus, here I've got P plus PR. Oops. And then still times the R. So this equals P plus PR plus PR plus PR squared. Combining my like terms, I get P plus 2PR plus PR squared. Well, really what we have here is taking out a P, similar to what we did here in the first expression. We've got 1 plus 2R plus R squared. Now what does that equal? You got to think about what can we continue to do here to try to get a general format. Well, this would equal P and then 1 plus R to the second. Let's just recap what I just did here. We start with an original principal and we add the rate. Now, second year around, we start with the new principal and then principal times rate, and you add to that. And I went ahead and I did all of the work. I distributed the P, and then again distributed the R, combine like terms, take out this P, and then factor. And you can see here some relationships that we're building with these terms. So if this is my end of my first year right here, you can look here, the end of my second year. The expressions are exactly the same except for the exponent. Well, I guess the only thing that we can say is let's do this one more time and see if this pattern continues. So in the third year, we would have the principal after the second year, P times 1 plus R to the second, plus the principal times the rate, 1 plus R to the second, and then times the rate. Let's go ahead and see, mathematically what this will give us here. All right, we've got P times 1 plus R to the second is 1 plus 2R plus R squared, plus P times, again, 1 plus 2R plus R squared, and we still have it multiplied times that R. I'm going to go ahead and distribute the P on the first one. So you have P plus 2PR plus PR to the second plus, I'm going to distribute the P and the R at the same time on this one. So plus PR plus 2PR squared plus PR to the third. Combining all of my like terms, I have a P plus 2PR plus PR is 3PR. And I've got PR squared plus 2PR squared is 3PR squared. And finally, I've got plus PR to the third. If you can see here, I got this pattern going on. I'm going to take out that P and I have left over 1 plus 3R plus 3R squared plus R to the third. Now, you may not remember this, however, you might. This 1331 is actually a pattern for binomials and taking binomials to a third power. So this would actually factor to 1 plus R all raised to the third. I just want you to take a second now and let's look at how all of this fits together. P 1 plus R to the first, that's the first year. P times 1 plus R to the second, that's the second year. P 1 plus R to the third, that's the third year. What we can do is then we can make the assumption that this would be my formula. Amount equals P 1 plus R raised to the T, where T equals the number of years. And that is your compound interest.